So next talk is about see in, so we have good AI systems. Let's assume that if how can we deploy those AI systems for better ROIs, return on investments. So the talk is from Anuj Gupta. He is an alumnus from our institute. He is a he did his master of science research in theoretical computer science here, and he is a co-founder of Gradient Advisors. So I'm requesting Anush to take the talk.
Sure. Thank you. Am I audible? Okay. I am aware of the fact that we are already running late, so I'll be quick. Okay. Just one call out. Most of you work in NLP trying to push the boundaries of the system. A large part of my work, owing to early stage startups, ended up being how do you build systems that lead to large business outcomes. Some of my work has led to acquisitions, funding rounds, even in IPO, right? So I'm going to give a perspective of how do you go about some of these challenges, right? Uh, if you look at today, AI in general, last 3 years, right, the whole scene has exploded. A lot of startups have come up. I don't think so. There's any company out there that is not doing ROI, AI, but there is one central problem to all of this. Where is the return on investment, right? A lot of money is being pumped in on the top, talent, data, compute, and all of that stuff. But it's only a handful of these companies that have seen any outcome, a business outcome. While this might not be a question for an academic institute, but for an industry, it's a very central question because by the very nature, it is the profit and loss that matters. You can build the greatest system, but if it doesn't move the business outcomes, it's a liability. If if you were to ask me what's the central issue and summarize this in one picture, I would put it as this, right? A lot of teams are trying to do AI purely on the basis of model, ignoring a lot of other fundamental stuff that is often needed, right? One of them is right use case. Are we solving the right problem itself, right? And part of this talk is going to be about how do you identify use cases that are likely to lead to large business outcomes. So if you are somebody involved in building AI ventures, then this would interest you, right? A lot of these learnings are generic in nature, can be applied to vision, speech, data science. Towards the end, I'm going to tie all of this to the NLP because that's the group here, where I'm going to bring out a counterintuitive insight on one of the most popular use cases of NLP in industry. Right? Okay, we're going to skip this. If you look at today, ask anybody where AI, Gen AI can be applied, people will give you a list of applications where it can be done. Uh, Probably given my background in theory and large part of my work in theory was around generalization, we have tried to create a framework by which you can take a use case and say, is this a good use case when applied this framework if you are trying to build an AI venture, right? So that is what it answers. Is this a good use case when you're trying to build an AI venture? Okay. Now we all understand that in a traditional software, when you're trying to build ventures, people typically go for applications which have high impact, low competition, and low effort, right? But these three parameters are not good enough when you're trying to understand AI use cases. What we have done is we have added a couple of more parameters to this particular framework, right? One is that traditional engineering, which is fairly natural to the people out here, right? If a problem can be solved using traditional engineering approaches, you should absolutely do that, right? In a lot of cases that I have seen in my journey, people are trying to apply AI where it is not even needed, right? So that's the fourth obvious point, right? The fifth point I'm going to come is when you're trying to solve a problem, you have just the right algorithm to be able to solve the problem. Now, what do you mean by just the right? It basically means that the algorithm is good enough to take care of large number of scenarios and edge cases. But at the same time, it should not be so very new that you don't know the pros and cons of it. Because when you put systems in productions and things go wrong, right, that can have a lot of repercussions when you're part of product teams as opposed to research lab. So this is where what you're trying to look is a problem for which you have algorithms which are fairly advanced and sophisticated that can solve large number of use cases. But at the same time, they should not be not so very new or cutting edge that we don't know the pros and cons of it, right? So that's the fifth point. Sixth, an obvious one again, but often missed in industry, pick scenarios where the cost of a mistake is low, right? Now, if you're trying to build healthcare, and that one, there are a lot of companies that are trying to apply AI to healthcare. Unfortunately, there's a dichotomy where in countries in APAC where this is heavily needed, people don't have money to pay for it. So it's not a viable business to build. A large part of this, if you do in US, there are consequences in case your system gets things wrong. Now, in the code of the law, it doesn't matter whether you're using a software or AI. A mistake is a mistake, and there are liabilities to pay, which basically means try and pick use cases where cost of a mistake is fairly low. Okay, so summary so far, impact should be high, effort should be low, competition should be low, AI should be the last resort for the problem that you're solving, right? You just have the right AI algorithm to be able to solve that problem fairly well, right? And the cost of mistake is low, right? Despite all the APIification that has happened of AI, right? So one of the big things that has happened in last 2 years is that you have what I call as off-the-shelf intelligence. You don't have to go and build a model on day one. You have these APIs or open source models that you can use. You can just make an API call and it will start to give response. It may not be the greatest response or the accuracy might not be very high, but the off-the-shelf models are or off-the-shelf intelligence is available. It basically means if you are a smart business or a product leader, you may not necessarily need an AI team on day one to build or assemble a system, right? Now, AI, despite all of this, still remains a fairly expensive technology, right? Because you still need data, compute, talent, and to be able to do all this, right? The purpose of any AI venture is not to advance mankind's understanding or do social good. It's all about money aspects of it, right? So it is crucial to keep economic considerations in mind from day one, right? Uh, what I have seen in my 15 years of journey, having worked with a lot of early stage startup, venture capitalists, and Fortune 500, a lot of teams tend to completely miss this, right? And I will give a small example to illustrate this point. AI can be applied in any organization at multiple points, right? And multiple places. One of them could be bottom line, where you're trying to improve the operational cost of whatever the company does and try to improve it, right? And other end of the spectrum is where you try and apply it to improve the top line itself, which basically means you're trying to either create newer products or you're trying to create new markets where the product can be sold, which is likely to bring in more and more revenue for it. Now, what I have seen consistently across 15 years is that when you're trying to apply AI at the bottom line, if your initial hypothesis is that you'll be able to improve something by X, you typically end up improving only by X by 3 or X by 4. Right? And why is that the case? There are multiple reasons. One is that AI is far from 100% accurate, right? We are far from there, which means that there's a constant effort that one has to keep putting in order to improve these systems. As these systems improve, what starts to happen rather than seeing exponential gains, what you start to see is that your the improvement curve starts to stagnate, which means rather than see exponential gains, you start to see exponential effort for a fractional gain. Third, if there is human aspects involved, which is often the case, human labor is always available to the. Thank you so much. Thank you. Owing to Globalization, human labor is often available in the APAC market for a much lower cost, which means from a business officer's perspective, you have an AI system and you have a human labor, and the human labor is fairly cheap available in these third world countries. So the arbitrage between the system and the human is not a lot, right? I don't know how many of you know, but one of the most impactful work that AI have done in industry is not in the customer support space and all of that, and I will discuss that point, but it is in the drug discovery. Drug discovery is often a multi-million, even multi-billion dollar game, which can take 20, 30 years, right? Professor Raj Reddy was yesterday talking about we are in all probability likely to see one or two more pandemics in next 20, 30 years. What COVID showed us is that the pharma companies may not have 20 and 30 years kind of timeline to be able to develop and test these drugs rigorously, right? Uh, AI have shown ways via which the entire drug discovery time cycle can be made much shorter, right? And if you look any of the large pharma companies, you'll see there are very large AI teams already present, as large as sometimes 500 people AI teams, right? So that's a very counterintuitive area where AI has gone on to show tremendous amount of result. But the point I'm trying to drive here is this was a very intelligent application at the top, which directly impacts the business rather than at the bottom line, right? Last but not the least, always build products where the market is willing to pay a very high price, right? They're willing to spend fair amount of money in order to get your products and services. So if I were to draw this as a spider graph, and unfortunately it has not been rendered correctly, but what you actually have are multiple octagons here. The one which is in innermost is low, then the medium, and then the high. So what this shows is that the impact should be high, effort should be low, it should be the top line should be high, competition low, traditional engineering should not be able to solve it, cost of a mistake is low, and the price point is high, and the tech advancement of the algorithm that you're using is just mature enough. So the gray area that you show in that you see in middle, if what demonstrates that if your use case falls here, it is more likely to lead to a multi-million dollar venture as opposed to other use cases, right? What I will now demonstrate is that one of the favorite applications of NLP is building building chatbots for customer support, right? We all have known, we all have seen. It so turns out that according to this framework, it is not a great problem to solve or a great problem to pick if the aim is to build an AI venture out of that. Right? Now let's try and apply this framework to that problem, and with that I'll end my talk. The impact is high. The competition is low. Why? Because there are a lot of companies that are doing this chatbot business, but there are hardly any companies that are doing it very well. Hence, I have said low. So if you can solve this problem very well, right, you have an edge. The effort is low. The traditional engineering falls short. We all know that you cannot write a bunch of rules on a traditional software that will solve this problem, right? Availability of just the right algorithms today in the world of LLMs and whatever we have seen in last 2, 3 years, right? These are fairly sophisticated algorithms that can solve this problem fairly well. Cost of a mistake, even if something goes wrong, that's okay. It's only a user experience. It's bad. It is not that it's going to cost anything much, right? Where this changes the game is that one, it's a top line because imagine your whole business is building chatbots and selling, right? So if you do any improvements, it will directly impact your top line. Where things start to go wrong is the price point of it. And why is that the case? Because in the markets, an alternative human agent is available anywhere between $300 to $500, which means for per seat, no matter how good your solution is, market will not pay you a price greater than this, right? And in my journey, I've been part of 3 organizations where either I was directly involved or as an advisor, right? And what I've seen is that often the margins that these companies have in terms of P&L, right? This is purely a profit loss viewpoint of the work, is very thin, right? It is not like other AI companies where you actually have a lot of revenue and a lot of margin. You can have a lot of revenue, but your margins are fairly thin, which actually does not make it a great use case for applying AI in industry, right? I hope I made sense. Sorry, I had to be a little quick, so I rushed through, right? Uh, just one last point, right? What Harshit talked about LLMs, and then this is what we tried to actually put together in the book, right? A view of things from industry. And it's not always about building the greatest model out there, right? How do you build systems that lead to large outcomes? Anybody who is interested in this area more, recently another book has come out. I would strongly recommend this book. The two folks from Princeton have actually done amazing work. So if you want to look at the hype and want to bring a more realism, this is a great book to look at. Thank you so much for your time. Thank you. Thank you. Any question I can take quickly? One question now, and I'll be available otherwise for any questions and discussions. Yeah, please. Sure. Yeah, please, sir.
So if you go to your chatbot building slide towards the end, yeah. So you say effort is low, but in chatbot we have to deal with many language phenomena like ellipses, co-reference.
Yes.
So are we assuming that all these are done by LLMs?
No. So when I say this, the idea is when you're building a system which is good enough to take it to market, right? Because then your revenues will start to come in and the wheel will start to move. In any AI system, getting to the system is always hard, right? Even if we look at Tesla, right, it is not that they are 100% autonomous, right? And that's primarily because AI always lives in this long tail of edge cases, which makes it extremely difficult. So when I said the effort is low, it is to build a minimum viable product which is good enough for you to start getting the traction in the market. That is what I meant.
Prototype to product.
Thank you so much. Thanks a lot.
Thank you, Anuj.